Rakukuru Ngolonda Walale. So good day, viewers all over the world. Welcome to Toidel online class. Today we want to talk about inverse of a matrix. Inverse of a matrix. If we are given a matrix, say A, which is given as A, B, C, D. This is a 2 by 2 matrix. So how do we find the inverse of this matrix? That is, how do we find the inverse of a square matrix generally? So for us to be able to find the inverse of a matrix, there are 4 steps that are involved. The first step is that we should find the determinant of that matrix. That is the first thing. So if you want to find the determinant of a matrix, of course we know that we multiply the element of the leading diagonal minus the element of the ordinary diagonal. That is A times D. That is AD minus BC. The determinant of the matrix A is given as AD minus BC. So if the determinant of the matrix is non-zero, that is, if we find the determinant of the matrix and you get a value that is not zero, non-zero, then it shows that that matrix has an inverse. But if the inverse of a matrix is zero, if the inverse of a matrix is zero, it shows that that matrix does not have an inverse. So a singular matrix, we have a singular matrix. A singular matrix is a matrix that has its determinant to be equal to zero. So a singular matrix has no inverse. But when you have a non-singular matrix, non-singular matrix, then the determinant is non-zero. It's not zero. Then a non-singular matrix has an inverse. So singular matrices are not invertible. No inverse. But when you have a non-singular matrix simply means that a matrix that has a non-zero determinant, then it has an inverse. So for us to find the inverse of a square matrix, we'll be talking about non-singular matrix. So how do we find the inverse of a matrix? As I've said earlier on, there are 4 steps involved. The first step is that you should find the determinant. We should find the determinant. That's the first thing. So it is the nature of determinant that will determine if the matrix has inverse or not. So once we find the determinant and it is non-zero, it is not equal to 0, then it shows that we can go ahead and find the inverse of that matrix. Then we find the minus excuse me, of the matrix. I'm going to use the example to tell us on how to find the minus of the matrix. We also find the cofactors of the matrix. Cofactor simply means minus with appropriate sign. That is cofactor. Minus with appropriate sign. Appropriate signs. So that's the meaning of cofactor. Then the first step is to find the adjoint. the adjoint of the matrix. So the adjoint of a matrix simply means that we transpose when we transpose the cofactors. So these are the first steps that will be taken for us to be able to find the inverse of a matrix. We find the determinant, we find the minus of the matrix, we find the cofactors, that is the minus plus the appropriate sign. Then we transpose. When we transpose the cofactors, that's when we get the adjoint. Then by formula, the inverse of a matrix is given as, let's say matrix A. The inverse of matrix A is given as the adjoint of A divided by the determinant of A. So this is the formula to find the inverse of a matrix. So it's given as the adjoint of A divided by the determinant of A. So I'm going to give example now. I'll give one example each on 2 by 2 and 3 by 3 matrix. Example 1. So the question says find the inverse of the matrix. So matrix A is equal to 2 minus 3, 4, 1. Solution. So matrix A is given as 2 minus 3, 4, and 1. So the first thing, step 1, is that we find the determinant of this matrix. In this case, now the determinant of this matrix will be 2 times 1 minus 3 times minus 4. Then 2 times 1 is 2, minus 3 times minus 1 is minus 12. So minus times minus, that will be 2 plus 12. So determinant of A is equal to 14. So in this case now, this matrix is non-singular matrix because the value of determinant is non-zero. So since this is non-singular matrix, we can go ahead and find the inverse. It shows that this matrix has an inverse. So we have gotten the value of determinant of A. Then we go to the second step, step 2. That's where we go ahead and find the minus. Let's find the minus of A. So how do we find the minus of A? Then for us to be able to find the minus of A, this is the first element along the first row and first column. So we find the minus of 2. These two now, if you want to get the minus of 2, we pretend as if we cover first row and first column. Of the matrix. So this represents the minor of the matrix. So this is the minor of the matrix. So we have gotten the minor of the matrix. So we can go ahead and find step 3 and find the cofactors. The cofactors of A, of set A. The cofactor is the minor. When we consider the minors, plus the appropriate sign. Of course, if you want to get the appropriate sign, the first one is plus. In order to get the cofactor, it will be so this will be 1, this is 4, multiplied by minus, that minus 4. The minus, this will be plus, then 2, this will be 2. So the cofactors of A is given as 1 minus 4, then 3, 2. Then the first step, step 4, is to find the adjoint of A. So the adjoint of A is simply means when we transpose the cofactor, that is first row to first column, the second row to second column. So if we do that, we are going to get 1 minus 4, then 3, 2. So this is the adjoint of A. Adjoint of A simply means we transpose the cofactor. Of course, when we transpose a matrix, we interchange row to column. And that's what we have done here. Then finally, the inverse of A will now be the adjoint of A all over the determinant of A. So then the inverse of A is equal to the adjoint of A is 1, 3 minus 4, 2 all over the determinant is 14. So that's what we get. And of course, we can rewrite this. We can write it as say 1 all over 14 into bracket 1, 3 minus 4, 2. So this is how to find the inverse of 2 by 2 matrix. So I'm going to give another example on how to find the inverse of 3 by 3 matrix. So I'll give example on how to find the inverse of 3 by 3 matrix. So let's take another example. Example on how to find the inverse of 3 by 3 matrix. The question is find the inverse of the matrix. Let's say B is equal to 2, 3, 5, 8, 7, 6, then 1, 4, 0. So in this case now we have 3 by 3 matrix. So how do we find the inverse? We follow the same step. The first thing that we are going to do is to find the determinant of B, because without the determinant of B, that's the first step. Once the determinant of B is not 0, then we can talk about the inverse. So if you want to find the determinant, we have done that before. That will be plus, minus, plus. And if you don't want to use this normal approach, you can use the Saros rule. So the first element there is 2. So in this first element now, is along the first row and first column. What if we pretend to cover this and this? What we have left is 7, 6, 4, 0. Then minus 3 into brackets. When we cover this and this, we are going to have 8, 6, 1, 0. Then plus 5, which is equal to, that's along the first row and third column. We have 8, 7, 1, 4 left. So this is equal to 2. Then what we do here is that we use the leading diagonal, we multiply the leading diagonal minus the other diagonal. 7 times 0 is 0 minus that's 0 minus 4 times 6, 24. Then we have minus 3 into bracket. 8 times 0 is 0 minus 1 times 6, 6. Then plus 5 into bracket. 8 times 4, 32 minus 1 times 7, 7. Then here we have 2 into bracket minus 24 minus 3 into bracket minus 6 plus 5 into bracket 25, that's 25. So that we are going to have minus 48 plus 20 plus 125. Okay. No, 3 times 6 is 18. This 18. 18. Then at the end of the day, we are going to have 143 minus 48. So that gives 95. So the determinant of B is equal to 95. So in this second example also, we found the determinant of B to be equal to 95, which is non-zero. So it shows that this matrix is a non-singular matrix and it has inverse. So we'll go ahead and find the minus of B, which is the second step. So how do we get the minus of B? In this case now, we have to be very careful. So the second step, the minus of B. So let me use this bigger circle. So if you want to find the minus of B, of course, since this is 3 by 3 matrix, then this is what we do. Let me first draft out what we are going to fill in. Okay, so in this case now, the first element is 2. What will be the minor of this first element? The first element is along the first row and first column. So if we pretend as if we cover the first row and first column, what we have left is 7, 6, 4, 0. So we go ahead and do that of the second. In this case now, we have first row, second column. So we have 8, 6, 1, 0. This is how to find the minus of each of the elements. Then when we want to find the minus of 5, 5 is along first row third column. So we have 8, 7, 1, 4. So we go ahead and find the minus of 8. First row, first column, second row. So we have 3, 5, 4, 0. Then we do the same thing for 7, which is second row, second column. We have 2, 5, 1, 0. Then we find the minus of 6, which is second row, third column. We have 2, 3, 1, 4. We move to third row. Third row, this one is along first column, third row. So we have 3, 5, 7, 6. Then 4 is along the third row and second column. So we have 2, 5, 8, 6. Then 0, which is the last element there, is along the third row and third column. So we have 2, 3, 8, 7. So the minus of B will now be given us. Look at, we use the leading diagonal. We multiply the elements along the leading diagonal minus the one along the ordinary diagonal. So 0 times 7 is 7. 7 is 0 minus 4 times 6 is 24. 0 minus, this will be 0 minus 24, and that gives minus 24. The second one is 0 minus 6, that's equal to minus 6. Then the third one, 8 times 4 is 32, minus 7, that is 25. Then we go to the second row. 3 times 0, 0, minus 4 times 5, 20. That's minus 20. 2 times 0, 0, minus, that's minus 5. Then 4 times 2, 8, minus 3. That is 5. We go to the third row. 3 times 6, 18, minus 7 times 5, 35. That's minus 17. Then 2 times 6 is 12. Minus 5 times 8, 40. That's minus 28. Then 2 times 7, 14, minus 3 times 4, 24. That's minus 10. Minus 10. So this will represent the minus of B. So we move to the third step. And the third step is to find the cofactors. The cofactors of B. Step 3. We want to find the cofactors of B. So cofactor of B simply means the minus of B, minus 24, minus 6, 25, minus 20, minus 5, 5, minus 17, minus 28, minus 10. So this is the minus of B. Then we now relate it with the appropriate signs. That's the meaning of cofactor. Cofactor simply means minus with appropriate signs. In this case now, the appropriate signs will be plus, minus, plus, minus, plus, minus, then plus, minus, plus. So in case of 3 by 3, this is the appropriate sign. So when we relate this, what do we get? This is minus here, times plus is still minus. Minus times minus, plus. This is plus. The minus times minus, plus, that will be 20. Here will be minus 5. Then minus times plus, minus. Then we have minus 17. Minus times minus, 28. That's plus. Then minus 10. So the cofactor of B is this. This is what we get for the cofactor of B. Then once we know the cofactor of B, then we can go ahead and we can go to the first step, step 4. That is the adjoint of B. So adjoint of B simply means when we transpose the cofactor, that is, when we transpose, simply we are interchanging row to column. So first row to first column, then we have minus 24, 6, 25. We have 20 minus 5, minus 5. Then we have minus 17, 28, minus 10. So this represents the adjoint of B. Adjoint of B simply means we transpose the cofactor. So when we transpose the cofactor, we get the adjoint. So this is the adjoint of B. So we have gotten the adjoint of B. So finally, the inverse of B, B inverse, is giving us the adjoint of B all over the determinant of B. So the adjoint of the inverse of B is now giving us, let's write out the value of the adjoint. That's minus 24, 20 minus 17, 6 minus 5, 28. Then we have 25 minus 5 minus 10. So the inverse of B is now this divided by The determinant of B is given as 95. We got it as 95. So this represents the inverse of B. And if we can rewrite it as saying 1 over 95, we can bring it out. We can say this is same thing as minus 24, 6, 25, 20 minus 5, minus 5, minus 17, 28, minus 10. So this is the inverse of B. This is the inverse of B. So for us to be able to find the inverse of a square matrix, the first step is that you find the determinant of that matrix. So if the determinant is non-zero, it simply means that the matrix has an inverse. And if the determinant is zero, it simply means that the matrix has no inverse. So once you find the determinant of the matrix, that will determine the nature of the matrix, if it is singular or not singular. Then you go ahead and find the minus of the matrix. Then from the minus, you find the cofactors, which simply means minus with appropriate signs. Then we now transpose the cofactor, and that is equal to the adjoint of that matrix. So if you're able to follow the four steps, then the inverse of that matrix will just be the adjoint of the matrix all over the determinant of the matrix. And I want us to also note, that the product of a matrix and a square is equal to unit matrix. That is, if you have a matrix B, multiply by the inverse of that matrix. We can use a matrix to multiply the inverse. Or if you have the inverse of a matrix, multiply inverse of a matrix, multiply by that matrix. At the end of the day, we must get an identity. We must get a unit matrix. So please, I want you to check this using the two example. That matrix in the first example, 2 by 2 is A. Just say A multiplied by A inverse. And let's see if you are going to get a unit matrix. A unit matrix simply means a matrix that has every element to be non-zero and 1 along the leading diagonal. That is, for 2 by 2, you are going to have 1, 0, 0, 1. This is what I'm talking about. So for 3 by 3, you have 1, 0, 0, 0, 1, 0, 0, 0, 1. So just try and check this. Use the matrix to multiply its inverse, or the inverse of the matrix to multiply the matrix, and check if you are going to get this unit matrix. So try and get that, but I'm sure you are going to get the unit matrix. So I would love to stop here. We're going to continue from there in our next class. Thank you.